I'll jump forward a little bit and say that we're very hopeful to get that bridge open to traffic today, but it will absolutely be by noon tomorrow. We're kind of torn in coming forward to you and scheduling announcements with being timely and telling you something as early and as quickly as we can with certainty. On a normal project, we'd wait until we had an hour and a day and we knew something was absolutely going to happen. But on this project, it wouldn't be timely and responsive for us to wait to do that. So we still have a degree of uncertainty about the exact hour of the opening of the bridge. But it will absolutely be by noon tomorrow. And the mayor has made it very clear it needs to be today. And that is in fact very possible, and I'm hopeful that it is in fact today. I'll get into some of the reasons why there's still some uncertainty about the exact time of the opening. On Tuesday of last week, we were fully open to traffic on the Flagler Bridge. The contractor, PCL, was working on putting in the new foundations for the new bridge. And midday, a little after 1, the leaves malfunctioned. Something called the span locks did not drive properly, and this was an indication of a serious problem with the bridge. We closed the bridge to traffic at that point, and it is not yet reopened. We also suspended the work of PCL, the contractor, in doing foundation work near the channel. They're still able to work away from the channel, but we cannot afford any further vibration near the Bascule Bridge foundations. So that work is suspended. What we observed was a total over 2 days of a little bit more than 1 inch of settlement of the southeast Bascule Bridge pier, a large block of concrete supported by the piles, including the new repair piles that we've spent the last 6 months putting in. 1 inch of settlement brings the settlement of that foundation to a total of about 2.5 inches over the last year, and that's extremely serious for 2 reasons. One of those reasons is the mechanical operation of the bridge, and the other reason is the structural condition of the bridge, largely the concrete and steel that is the structure of the bridge itself. So we need to look independently at those two, and they react differently to settlement. But settlement is a very severe condition for both of those. The immediate impact of the settlement is that the Bascule Bridge, which is a very complex piece of machinery, is out of alignment and no longer works. And you've heard the terms span locks. When the leaves go down, span locks drive and connect those 2 leaves to each other so that they don't bounce and move when traffic goes on them. When the leaves go out of alignment a little bit based on differential settlement, as they have, and they did last Tuesday, the span locks don't drive, and that's a clue that we've got a serious problem. So, once the settlement stops, and it has stopped, it hasn't settled, I think over 3 days. Is that correct? Over 3 days, no settlement. So we believe that this episode of settling has stopped, and we would not expect it to resume unless we again created construction vibration from working on the new bridge foundations in the vicinity of the channel. So we think it is now stable as far as the current level of settlement. Going to the 2 issues that we have with the settlement, one is the mechanical condition of the bridge. Once the settlement then stabilized PCL, the contractor could go out there and repair the leaves. You've heard this described several times in the past year. They've had to do this process. They remove the span locks, they adjust them, they put them back in, they work on the leaves so the leaves open and close properly, the span locks drive. That has all occurred to this point. The leaves open and close properly, the span locks drive. Another mechanical component is called the live load shoes. I don't know if we've been in a meeting and talked about that component before, but when traffic drives over the bridge can bounce up and down, which we can't have. And we shim portions of the bridge to make sure that everything is level so that when traffic goes over the bridge, the 2 Bascule Bridge leaves don't move at all. And right now, there's a little bit of play in them and they're moving, and they have to be shimmed with something called live load shoes. And that is being done today. We hope to conclude that and reopen to traffic today. That's the expectation of the mayor. And if it doesn't happen today, which I certainly hope, it will happen by noon tomorrow. But that's the ongoing activity, which is to ensure that the bridge does not move under traffic. The second issue is the structural condition. When you have settlement of one of the four corners of the bridge that is differential from the others, you create stresses in the concrete. And those stresses will result in cracking, and they could ultimately result in failure of the bridge. And our engineers have carefully inspected the bridge, both underwater, at the pilings and the pile cap, and above water, where we can observe the concrete and check for cracks. All concrete has cracks. What is the degree of cracking? Do we show new cracking? Have cracks widened and gotten larger? This detailed inspection then is reviewed by our structural engineers, and they run calculations. They also take the degree of settlement, which creates known stresses in the bridge, and run the calculations to determine whether in fact the bridge is still stable and safe. And our conclusion with the visual inspection both underwater and above water is that the bridge is still sound. Our conclusion with running the calculations for the stresses in the concrete beams is that the bridge is still safe and traffic can run on it. The margin of safety of that bridge, every time that we have additional settlement, becomes an even greater concern, but we are confident that at this time, with this degree of settlement, the bridge is safe, both mechanically and structurally, to reopen to traffic. We would also expect that the bridge is stable indefinitely as long as we don't work on the new bridge. But ultimately, we have to work on the new bridge, and I'll be getting to that. The stress, the load that has to be carried by the foundations is the weight of the bridge itself, plus the weight, the live load, the weight of the vehicles on it. Even a heavy truck, the comparison of the weight of that truck to the weight of the bridge itself is very small. We're not really concerned about the weight of the vehicles. Why then do we not allow 4 lanes of traffic? One of the conditions that we have when we get differential settlement of one corner is that the leaves, they settle differentially, so the 2 leaves do not match up to each other anymore. One of the leaves is rotated. We saw this effect previously when this started last fall. We saw it in the spring, and we see it again now with the new settlement, that the 2 leaves are at the same vertical elevation and can be adjusted in the middle, but when one leaf has rotated, the 2 leaves do not line up vertically. They have a jump on the outside lanes. And it's not going to be good for vehicles to drive over that bump. It's not going to be good for the bascule leaves to have vehicles pressing down on it when they hit that bump. So that's the reason. It's not the weight of the vehicles that we've decided to go with 2 lanes. It's because the leaves vertically do not quite match. And if some of you media have a chance to go out and see the bridge when it is in fact back in operation soon, you will be able to observe that. How many inches do you think might be the vertical offset at the edge?
About 2.5.
2.5 inches? That'd be quite a jolt if you drove over that in your car, but in the center of the bridge, it in fact matches correctly. So it is not the weight of the vehicles, it is the misalignment of the bridge leaves that cannot be corrected at this time.